Hey, what's up, guys and gals? So, 5 years ago, almost to the day, actually, Greta Thunberg made a prediction about we had 5 years to change what we're doing to our planet and environment, or else it'll be too late. She said, I think that she got that from a top scientist. I don't know if it's a coincidence, but I made that same prediction myself. Not happy that I did that, but that's the way that it is. So, but now we have to come together, work harder, because I don't want to be the harbinger of the end times, man. I want to be the harbinger of salvation. All right. So let's backtrack a little bit here. I mean, one, we need to get moving here. We need to get this thing going. People need to understand that this is actually really a serious issue, but that there's also like this is a solution. We can create sustainable energy, and that's what I'm going to talk about in this, and just explain the photoelectric effect and its uses in that. Okay, so to understand the photoelectric effect, well, what is that? I'm going to try and keep the science as simple as possible so that anybody can follow this. Ultimately, the photoelectric effect affects all things on this planet. It is like it's the circle of life. It's we all depend on this: trees, us, the planet, the water table, even. Okay, so plants have it, right? They have what we call photosynthesis, which is ultimately the photoelectric effect. When we're in the sun, we create vitamin D, which is ultimately the photoelectric effect. When the solar rays hit solar panels, it creates usable energy, the photoelectric effect. Now, the same thing happens, and we should be able to quantify this. That when you have an abundance of energy, like a lightning bolt will leave a trail of H3, like a hydrogen. It's explained in the 6 days of creation. On the first day, there was light, which is energy. And then from that energy, and on the second day, there was atmosphere, which is hydrogen, which is water. Okay. So when you have an abundance of energy, it makes water, hydrogen. And I would go on to ask the question, is this photoelectric effect a fundamental force? Is it the fifth force? Ultimately, I just said that because I think it's a cool soundbite, and I might name the video after that. But because we could go on to talk about the fundamental forces, how gravity is ultimately just electromagnetism, and how the strong and weak nuclear forces, this. But that's pretty advanced science, and that's not today's conversation. So this does tie into understanding gravity and how the Earth's core works. So gravity, which is just charged mass, it's energy at the Earth's core. It's sustained there by all the pressures and everything. You can't get out from there, right? It's what charges the lava. So there's all this energy at the Earth's core, which is ultimately what we call gravity, which is electromagnetism. So you got all this energy down there, and all that energy is actually producing hydrogen, water. And so to keep that there, and I keep talking about the cause of climate change, it's all the pressure from above, all these fossil fuels, keep that core pressurized, keep all the energy down there pushed together, and understanding that is actually something that we can use for what we call fusion energy, or for, we might want to call these systems that we can create to make sustainable energy, like photoelectric energy or fusion energy, because we're just using, ultimately scientists are just using these basic terms so that people can kind of understand and follow it to keep it simple. But so is this photoelectric energy, and how can we use that? Because I've talked in the past a lot about fusion energy and creating these sustainable systems to produce energy for us to ultimately save the planet and to lead us to our salvation, to help. I mean, this is part of it. This is changing our economy to a sustainable energy economy and sustainable energy way of living. We can do these amazing things with this stuff, you guys. Amazing stuff. Planetary saving stuff. You know, when we talk about sustainable energies and stuff, when you create that, when you have all that energy in there, it creates that pressure, and that pressure in itself you can use to spin turbines and stuff, and then use it for water, see the desert bloom with it, and then you put energy into it, so you can take some of that energy out. You can already use that energy that you're putting in. It creates a bunch of heat, so just the cooling to cool the system, you can use that to, again, pressurize systems. So there's multiple ways of getting energy off of these types of devices. I've talked a lot about it in the past, and I can revisit it at any time. And let's finish this thing so that so we can save this planet, because time is of the essence here. So that's explaining gravity. So we have all that energy down there, and that's producing that hydrogen, like I was explaining. So all that energy is actually going through the crust, going through the planet itself, right? That's gravity is going through there. So it would be creating this photoelectric effect everywhere. So the more energy you have down there is going to create even more hydrogen, water, and that ultimately sustains our systems, our water table. So, and it's measurable. The loss of energy due to fossil fuel extraction is notable, because essentially the atmosphere is a reflection of the Earth's core, right? So you can measure it in multiple ways. It doesn't get reported very often, but we're actually losing our vertical atmosphere, which is ultimately gravity, energy at the Earth's core. So that's shrinking. That is a reflection of the loss of energy at the Earth's core. The polar vortexes, used to be these two kind of like jet streams, the vortexes of wind we used to track. We still track. But they used to be these nice two circles around the North and South Pole. They've kind of broken down. It's been noted that they've gone all the way down to Texas, and they're supposed to be up there around that Arctic Circle. So that just shows we're losing energy at the Earth's core. The jet streams across the equator, the migration of the northern lights, all of these things are related to loss of energy at the Earth's core, which is ultimately the cause of climate change. But the great news is that we can do this, that we can put this stuff in make systems and use it to quench the thirst of those who are thirsty, use it for energy to power cities. And it can lead us to salvation and to lead us into this new era. So ultimately, it's just touching on the subject here. I think that's pretty much about it. So I leave it with the question: is the photoelectric effect its own force, or is it part of nuclear and electromagnetism, like a cross in between? It's a question that we can answer at a later date. Thanks, guys. Talk to you later. Ultimately, it's really just an interaction between energy and atoms. Key takeaway from this conversation would be that forcing charged mass magnifies the energy output of that mass. So when we're talking about the Earth's core, like I mentioned, you're forcing a bunch of charged mass, charged electrons, charged atoms, whatever term you want to use, doesn't really matter, into proximity, magnifies the energy of the output. And that's kind of what we're doing with all these like electromagnetic reactors, type reactor things that we're making. We're forcing these electrons into proximity. It's putting out a whole bunch of energy that we're able to use. That's the key to understanding how the Earth's core works. It's also the key to understanding how to create sustainable energy, whether we call it a Gaia reactor, a photoelectric reactor, a fusion reactor. It's a principle in there. We can get into, I've talked about it before, getting into explaining ways to do this, because it's actually really simple. And anybody needs clarification, I'm happy to help. So let's get back together here, you guys. Get talking and come together, save this planet. Talk to you guys later. Take care.